Alright, we are going to be graph linear systems in order to solve word problems here. And we're going to start off with this real world problem. Rock and Bowl charges $2.75 per game and $3 shoes, so we must be talking about bowling here, right? Super Bowl charges $2.25 per game and $3.50 for shoes, which you can write down here. Okay. We want the approximate number of games played for each, which the total is about the same. So this first one right here is, I'll just put R and B. Rock and Bowl is through $2.75 per game, a start of 3 because you have to have shoes, right? And this one will say Super Bowl SB, which is $2.25 instead of $2.75, but a higher price for shoes, $3.50. So let's go ahead and try to graph these. Let's graph this guy first. We start at 3 right here, and $2.75. That's a little tough. Let's go over 2, right? Instead of going over 1 and up $2.75, we're going to go over 2, and from here I'm going to go up, would it be $5.50? So 1, 2, 3, 4, $5.50, right about there. Alright, this guy starts at $3.50, so it starts a little higher. And instead of going over 1 and up $2.25, let's go over 2 and up $4.50. So from $3.50 right here, we go up 50, and then 1, 2, 3, 4 right there. Somewhere in there. So it intersects before 2.8, but 2.8 is probably the closest whole numbers we have. So a little less than 2 games, and the cost would be about $8. Alright, not quite, but it's a really good estimate. Obviously they've passed past 2. This guy right here that charges more, his at 2 it's already higher. We can see it getting higher right here. It works, right? If I plug into 8, I get really close. I get $8.50 is approximately 8 over here. If I plug this guy in, this is actually 8 and 8. And so which would cost more if you bowl 1 game? If you bowl more than 1 game, well, when you bowl more than 1 game, the R&B starts costing more. And you can tell by the rate of change, right? Since this one has a higher slope or rate of change, that it's eventually going to pass the other one. And that's as simple as it is. Let's do one more. There is only one more. Alright. So, Video Club charges 10 for a membership and 4 per movie. Looks like that. The other, that's A, and B charges 3 for a movie and 15 for a membership. So let's do this. So let's start at 10 with this guy. This is A, and there is no good scale for if my slope is 4, right? But I could go up 20, right? This would be the same as going up 20 and over 5. That's still a slope of 4. So I'm going to go ahead and go up 20 and over 5. So let's see, 10, 20, and over 1, 2, 3, 4, 5, and should cross about there. And my slope here is 3, and again, no great scale for 3, but I could go up 30, right? 3 over 1 is the same as going up 30 and over 10. So let's start at 15, which is right here, and if I go up 30, 10, 20, 30, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to get something that looks like that, and they're crossing approximately here. Oh, it's like 6 and 34 maybe. 6 and 34. And
5, 36,
let's
37.
Stop, son. Let's test it out. If I plug in 6 and 34 here, I'll get 4 times 6 plus 10. Well, it works here. 34 equals 34. Let's try it here. If I plug in 6 and 34, 34 equals 3 times 6 plus 15 34 equals, what is that, 18 plus 15, 33. That's a really good estimate. All right. When a linear system is a graph, how is a graph related to the solutions? Right? Where the graphs intersect. Those are your solutions. How does graphing help you solve the system of linear equations? The graphs show solutions. Alright. There are also points of my son told me I spelled graphs wrong. She's right. He's right. I left that H out. Points of intersection. There it is. So, I have no idea where we have that shadow there. It's a little strange.
Yes.
But